The journey through the evolution of human thought as to the primordial questions, what is nature and what are we made of, goes back to the birth of pre-Socratic philosophy 2,700 years ago, with the Greeks, who thought logical reasoning concluded that all natural events could not be the result of supernatural events. The first Western philosophical movement with this type of thinking, led by Empedocles 2,500 years ago, proposed that all matter would be composed of four fundamental elements: water, earth, fire, air. Contemporaries of Empedocles, Leucippus and Democritus, created atomism. Matter could not be divided infinitely, but divided it into a finite number of times would be found a very small, indivisible, impenetrable fundamental particle, which has been given the name of atom. Remaining unproven for 2,000 years, it was only in 1803 that English chemist and physicist John Dalton took up the hypothesis and presented his idea that matter was made of tiny particles. He conducted a series of experiments with various substances and concluded, matter is really composed of small and indivisible particles. Dalton's atomic model became known as the billiard ball model. In 1897, J.J. Thomson, conducting experiments with cathode rays, discovered a new fundamental particle, the electron. He concluded that the atom was not indivisible, but rather like a raisin pudding. The pudding mass would be spherical and positively charged, whereas the raisins distributed by the pudding would be the electrons, which have negative charge. In 1911, New Zealand physicist and chemist Ernest Rutherford enters a story. During an experiment, he observed the behavior of the particles and concluded that the atom was actually a large void with a small positive nucleus around which the electrons were orbiting. This model became known as the planetary model. But wait a minute, if protons and electrons have opposite charges, why don't they attract each other? The electrons in circular motion would emit radiation, lose energy, and would walk towards the nucleus, causing the atom to collapse. Why doesn't this happen? The Danish physicist Niels Bohr's model had the answer to that. To explain the imprecision of the previous model, Bohr suggested that the only way the electron would not clash with the nucleus would be if it didn't lose energy during the movement. Let us now look at the nuclei alone. We know that the hydrogen nucleus contains only one proton. On the other hand, the iron nucleus has 26 protons. So why do not these protons repel each other, since they have a positive charge? The answer is obvious. That's what neutrons are for. Now we know that protons and neutrons are not fundamental. There are constituents in these particles. The names we put on these colored particles are quarks and gluons.